Yeah, we can
Yeah,
see.
yeah, okay, thank you. Hi all, thank you and welcome to our session, Azure Data Factory and Bicep, here at Data Community Meeting Austria. Purpose of this session is to provide you a very quick overview of these two services and show you how you can create Azure Data Factory component using Azure Data Factory and Bicep side by side. So myself, I'm Alpa Budbeti and I'm working as Azure consultant at Cluster Reply UK. And I would like to ask Ben to introduce himself. Yeah.
Yeah, I'm Ben. I'm a data platform MVP, and I'm doing the Bicep part today. Um, I've seen many of Alpa's presentations, and so we decided to do a joint presentation on Data Factory and Bicep, which is really cool, and I'm really excited to be here today. So thanks for having us, and I'll switch to German for a second. Ich sehe den Chat auch, also wenn Fragen sind, dann kann ich die da auch sehen. Das ist der Vorteil, wenn man zu zweit präsentiert. Okay, Alpa.
Okay.
I would suggest we start by talking a bit about Azure Data Factory.
Yeah, sure. Yeah. So let's move into today's agenda. So today's agenda is divided into 6 parts, and again we're going to give you a quick overview, and then we're going to create these components using Azure Data Factory and Biceps. So now let's start with Azure Data Factory. So what is Azure Data Factory? So Azure Data Factory is a cloud-based data integration service that orchestrates and automates the movement and transformation of your data at a scale. It is also Azure Platform as a Service and it's a serverless. So because of these two reasons, you don't need to worry about compute infrastructure. Azure will do it for you. So like you don't need to worry about operating system, web server configuration, or CPU or GPU or like that. Azure will do it for you. So you can fully focus on implementation, and that's why you can build it very, very quickly. And because of the above two reason, you only pay for what you have used. For example, you have Azure Data Factory and you have pipelines. You may have 100 pipelines as well. But if your pipeline is not running, then you won't get any charge for execution. However, you get a small amount of charge for storage, which can be negligible. So it's a cost effective. And last but not least, it's a low code or no code solution. So you can quickly build your pipeline or workflow using drag and drop few components and set few properties. So now let's move into next one, which is what can you do in Azure Data Factory? So
Maybe
you,
Alpa, maybe
yeah,
we should clarify one thing,
yeah,
because you say it's low code, no code, and you couldn't do everything with dragging and dropping.
yeah,
Um, I'm a nerd. I'm a geek. I like writing code, so I think it's cool that you can also do it by writing code and not only
yeah,
by dragging and dropping. Of course, what we should mention, because that was a point for discussion at our last presentation,
yeah,
is that writing code is not for a one-off data integration solution that you want to build, but if you want a repeatable process, if you want to ship a data factory as part of a software as a service solution or something like that.
yeah,
So that's of course a different scenario than building API system or something like that. But still, I think it's quite cool to see that it is possible to use Data Factory in such a scenario, and that's something that we will show later in this presentation.
yeah, that's correct. Yeah. So now let's move into what can you do in Azure Data Factory. So you get idea why you need Azure Data Factory. So let's see first one. So you can copy your data. So you can copy your data using copy data tool, or you can use a copy activity inside your pipeline. So you can copy various data sources. So for example, you can copy from other cloud services. For example, AWS, Google Cloud. You can copy your data from on-premise system like SQL Server, Oracle Server, or SFTP. You can copy your data from system like Salesforce and CRM 365. You can use like custom activity or Azure function or HTTP web call or REST API to move your data as a source. So you select your source and then you set few properties and then you select a destination and you move your data from one or another sources. So these are the sample sources. But in Azure Data Factory for copy activity, you can have around 100 data sources available, which you can use as a source or a sink or both of them. So this is the link which will help you to find out which data source you use as a source or as a sink or both of them for a copy data activity or copy activity. And this is called a data movements. So you can do a data movements in Azure Data Factory, and you can do it very, very quickly if you use no code or low code solution. And this is a very important part in your modern data warehouse like ETL or ELT, because you do data movements. So now let's see what else you can do in Azure Data Factory. So you can do a data transformation. So for data transformation, Azure Data Factory is using Apache Spark cluster. Like it's used a mapping data flow, but behind the scene it's using the Spark cluster. So it spin up the Spark cluster very, very quickly behind the scene if you use Azure data mapping data flow. And without writing a code in programming language like Scala, Python, and Java, you still can get same features in using the Azure Data Factory mapping data flow by just drag and drop components if you have choose that method, like no code or no code method. So if you are familiar with database language like SQL programming language, SQL programming language, then it's similar to here. You can see that you have all components available here. Like you can join to data source. One data source can be XLS file and CSV file, and one can be JSON file. You can have a more than one
No,
data.
no, Alpa. We don't use Excel files.
No, it's CSV and
Yes.
JSON. CSV and
Yes.
JSON. Yeah, but you can even you can use XLS, but there is no sync available for XLS file,
Yeah.
uh,
And we should
as
not
well as for XML.
encourage using Excel as source of sync
Yeah, yeah,
for
yeah, but
religious reasons.
yeah, you are right. Yeah. So yeah, so you can use like different data sources as well. So you select your data source. For example, it can be like a SQL server, on-premise server, or a Snowflake, or a Azure SQL database, or like that. Then you apply some transformation. So here you can do join two data sources. You can apply some calculation. You can add a new column, like derive column. You can union a few things. You can add aggregation, and so many things you do here. Transformation, like how you writing a query, SQL query. Same thing you can do it here by just drag and drop components, and then you can select your destination or sink. So these are the simple sources you can use. So this is called data transformation. And for mapping data flow in Azure Data Factory, there are 18 data sources available. So if your source is not available in this list, then you can use a common used data source, for example, blob storage or Azure SQL database. And this is a link which can help you to find out which data source you can use as a sink or as a source in a mapping data flow. And this is called a data transformation. Again, this is also very important in your modern data warehouse because it's do X load transformation. So like extract, load and transform, or extract, transform and load. So now let's move into what else you can do it in Azure Data Factory. So when you create a components in Azure Data Factory, behind the scene it's generate a JSON code for you. And this code is ready for your source control, and which you can use for your continuous integration and continuous delivery. And it provide you a Git integration using the UI. So you can use Azure DevOps Kit or you can use a GitHubs. You can also monitor your Azure Data Factory component using UI, and you can manage your Azure Data Factory component using the UI. So these are the things you can do in Azure Data Factory. Now let's move into key component of Azure Data Factory. There are five main key components of Azure Data Factory, uh, which let's start with first one, which is a linked service. So if you compare linked service with SSIS, then it has a connection manager. So it's similar to that. It holds the connection string. It holds the address of your source or sink data source. So that is a linked service. Next one is a dataset. So datasets is like metadata of your data or reference of your data or a structure of your data. So for example, your link service pointing to a Azure SQL Server database, then your data sets in form of the table. But if your link service is pointing to a REST API, like it has address and it authorizes a REST API data source, then your data sets in form of the JSON file. So your data set can be in a like file format or table format or a folder formats. So it have a like file, table, and folders, and you have different file types as well. If you have file, then like CSV and like that. So next one is activities. So as we said, it's no code or low code components. So in Azure Data Factory, you can drag and drop. So at that time, you have ready-made components. But if you comparing this with any programming language or any database language, so you writing your codes there, you declare your variable, you set your variable, you use a for each loop and whiles, and you write down logic. So same thing if you want to do it in Azure Data Factory in no code, low code way, then you can have a ready-made component which is activities. So you can drag and drop that activities. So it has like so many activities available, like for each loop activity. It has like if activity. You can have connect with other Azure services, for example, Azure Function, Azure Machine Learning, Azure Databricks. So those are the activities available here. So like this is a simple one, and that other generic one as well. So those are the activities which do a specific task. So now let's move into fourth one, which is a pipeline. So pipeline is nothing but is a logical group of your activity. So which perform a which perform the business requirements, or it's like step by step. It has all information. So it's you have activities in a parallel or sequential form as well. So in this example, you can see that this is a metadata activity and this is a for each loop activity. So output of metadata activity is the input of for each loop activity, which is a sequential one. But you can have a parallel one as well. So here you can see that there are two activities, and you are sequentially connected with here, and these two activities is sequential. So it's like mix of both, like sequential, parallel, or sequential, or mix of both. So this is the pipeline. Now let's see a triggers one. So once you have ready your pipelines, you need to run your pipeline. So you can do by just clicking on a debug button, so which debug your pipeline, or you can trigger it. So you can have a different kind of triggers. For example, time-based trigger. You can have a blob-based trigger when file arrives or delete from blob storage, or you can create your own custom triggers as well. You write down your codes in a Logic Apps, Azure Function, or C Sharp, or a PowerShell, or like that. So these are the main five components of Azure Data Factory. So now let's move to biceps. I would like to hand over to Ben.
Yeah. Maybe you can share because it's only two
Yeah,
slides.
yeah.
Um, so let's talk a bit about Bicep. What is Bicep? Many of you might have already heard of ARM templates, used ARM templates, seen ARM templates. Actually, the JSON format of Data Factory resources that Alpa mentioned before is ARM templates that are created under the hood. And Bicep is like the newer, better, beautifuler version of ARM templates. And it's a domain-specific language made for declaring Azure, describing Azure resources, and then deploying them, meaning that you create, that you write in your template file the resources that you would like to have in your resource group, then you deploy that template, and the Azure Resource Manager ARM or the templating engine will take care of creating the right resources in the right order for you. So it's a desired state configuration where you write down the state you wish your resource group to be in, and then the resources are created in that way. So basically, it's a way of defining your infrastructure as code and deploying it. The advantages of ARM is that it's much better readable than ARM. ARM has become very cluttered over the years. And it's a bit easier to develop because there is very good Visual Studio Code integration, which you'll see later in the demos. But then the question would be, why would I even want infrastructure as code? So Alpa, maybe you could advance one slide.
Yep.
Thank you. So why would one want to define their infrastructure as code? Well, the first thing is it's controllable. You can add that code to version control. You can implement code reviews. You can have deployment pipelines automatically deploy stuff, which is a good thing. Also, you can use this for auditing. So you will know who made what change to your infrastructure, when and why, because we all have sensible Git commit messages, of course. So from the commit messages, you can make out what change was made and why. You'll have a history of changes. You can see how your infrastructure developed over the time. And most important, your deployments will be repeatable. You'll be able to deploy the same thing several times over and over again without much effort or without any problems. You'll have the same environment. If you deploy the same template twice, you'll have the same environment twice in 2 different resource groups, in 2 different regions, whatever you want. Templates also enable you to enforce naming conventions, because if it's not people like me clicking in the Azure portal, then you can review namings before you deploy. You can create names from variables. You can ensure that the names are created in a consistent way, which is also quite important if you're using resources in the cloud. It helps if you can find things again and know what they are from their names. And by that, it also reduces errors. It reduces the number of typos you have in your deployments. I mean, how often have I created a SQL database where I've forgotten the L? So I had a CQ database or something like that. These things happen because we're all human, and we can reduce these errors by putting things into code, by creating names for resources, by creating things automatically, and by having code reviews and having a principle where 2 people at least view the code, and you have a higher chance of catching typos, other errors. Plus, infrastructure as code gives you a possibility to do disaster recovery if your environment is down, and you can spin the same environment up by running a template that might take a few hours, but not as long as creating everything from scratch and trying to remember what was in that resource group. So it's also a form of disaster recovery and a form of documentation, because your code basically documents the environment that you built. And together with the sensible commit messages that we all write, this helps you document the reason why things are the way they are. So basically, we can say infrastructure as code is a good idea. Plus, if we want to ship code in a repeatable manner, not only for different environments, but for example, for different customers, make sure that every customer has the same pipelines, the same names of resources so that we can work with them. Then defining all of that as code can be very, very helpful. And it'll turn out, and you'll see in a moment, that we can do lots of things that we do in Data Factory by defining the infrastructure, the data factory, the components of the data factory as code. So many of these aspects you will be able to see throughout the demos that will start shortly. And now we'll switch over to demo time, show you some stuff hands-on. And basically the idea is that Alpa will create stuff walk you through an environment, create stuff in the data factory, and then I'll show you how easy it is to do all that with Bicep. Then in the end, you'll all say, why should I click in Data Factory if I can do it? No, that won't happen probably, but we'll give you an idea of how complex it is to create those things that Alpa will walk you through now in Bicep, to give you an idea of how hard it would be to have a repeatable deployment of such an environment. So Alpa, please take over and introduce the environment. And by the way, if I look at this resource group that you've just shared, there's another thing regarding the reducing of errors when doing manual deployments. As you can see, Alpa chose 2 different regions for her resources. If I have the region in my template, I can ensure that all resources are always in the same region. So that might be a typical error that you make when you deploy something. that you just choose some region and you forgot whether you chose US East 1 or 2. And having that in a template will reduce, for example, that kind of error as well.
Yeah,
So Alpa,
definitely.
take over.
Yeah, thank you, Ben. So here you can see that this is our resource group, ADF Biceps, and we have 5 resources. And let's start with one by one. So first one is a key vaults. So key vaults hold the secrets. So it's hold the secret for our data source. So we have a 2 data source. Our source is blob storage and our sink is Azure SQL database. So like source is a blob storage and database. So here we have a secret. So we have 2 secrets because we have 2 data source. This is holding the access key or connection string of a blob storage, and this is holding the connection string of database, Azure SQL database. So we have used here key vaults because it's secure, and another reason is hold the secrets in the center place. So you don't need to change if you have more than one system, then you don't need to change them because you only need to change secrets in one place and it can be used by any systems. So that is another advantage. And in order to use your Azure Data Key Vault secrets in your Azure Data Factory, you need to give a access policy here. So this is a very important thing because once you create here permission access policy, then and then your Azure Data Factory can have access of your secrets. So that is the one thing. And so yeah, so these are the key vaults. And let's go to another one, which is this is Azure SQL database as a sync database. So I have just deleted here. So let's see here. So nothing is there because when we run pipeline, you will see data here. And next one is a blob storage. So this is our blob storage as a source data source. And we have a files here. So when we run pipeline, so end of the execution, this data should go into a Azure SQL database. And let's move now with data factory, which is here. So in our data factory, we have these are our link service. This is a managed tab, by the way. This is a managed tab of Azure Data Factory. And here you can have a link service. So you can create your link service so you can have access of your particular data source. So we have a blob storage link service, keyboard link service, and Azure SQL database link service. And here you can see that behind the scene is generate a JSON code, as I said you earlier as well. And you can see who is accessing your link service by just seeing here.
Maybe we cannot stress enough how important it is to use Key Vault.
Yep. Yep.
This is really best practice.
Yeah. It's yeah.
Really important. I find that many people from data community tend to not see the importance of using a service like Key Vault, and I think it's one of the most important services out there. So I just would like to stress, if you build something like that, use Key Vault.
Yeah. Yeah, Key Vault is a very, very good features. It provides security as well as a extra benefit of maintenance, like, and it's very easy as well, and it's not costly as well. So here you can see that this is a URL of your Key Vaults. That's it. So you first need to create your Key Vault link service, and then you can see how important it is. So here you can see that
maybe Alpa, that's not entirely right. That's not it altogether, but you need to grant access to the managed identity of your data factory to access the secrets in your Key Vault. It's also something you have to do.
Yeah. Yep. And you can see that here, no one knows which SQL database or blob storage I have used, because here I just know the secrets name. So it's like if you have engineer teams and other teams, then it's your engineer team don't know about secrets. It's like secure, it's provider security. So these are the managed tab. So here you can create link service and integration runtimes, and you can connect your Git repository as well here. And you can have ARM template, so you can export and import ARM templates as well. If you are new and you want to do, but that's a manual way and it's not recommended way. This is a monitor tab. So here you can monitor your pipelines execution, trigger execution, and many more. And this is our third tip. So here you can create your pipeline, data sets, data flow, and Power Query as well by just clicking on plus button here or by just clicking on three dots here. So let's see now how you can create a link service. So let's go to manage tab. And here you can just click this button. So first you create your link service in your Azure Data Factory. And these are the data source available. As I said, there are more than around 100 data sources. So these are all data sources you can pick. So let's pick blob storage. So you just select source type and then you click on continue. Then you give a suitable name. You provide description and you select integration runtime. So this is a 6 component in Azure Data Factory. As we said, it's a platform as a service and serverless. So you don't need to worry about compute infrastructure. But for executing your pipeline, you do need a compute infrastructure. So this integration runtimes provide you a compute infrastructure. So here you can see that by default, auto resolve integration runtime is available when your source and sink both are in a public place, public internet. But if your source and sinks one of them are in a on premise, for example, SQL Server or Oracle database or like SFTP, so at that time you need a self-hosted integration runtime, which you can create by just here this button in few button clicks away. So that is the one. So let's select this integration runtime, and here you can select keywords. As we already have created keyword link service, so you just select that. So it will give you all secrets in that particular keywords. And then so I have a two, so let's select a blob storage one, and then that's it. Then you can click on test button. So it's successfully connected with the keywords. That's it. You just click here and then that way you can create your link service. So I have already created link service, which is a Azure SQL database related link service, blob storage related, and key vault related. This is first one. First, I need to create key vault one, and then after these two. So these are
Now,
the link service. Yeah,
now let's have a look how this will look in Bicep.
yeah,
I'm eager to show some code. I've
yeah,
seen too much UI today. I want more code.
yeah, yeah,
Okay, so I'll start sharing before
yeah,
you take over again.
yeah.
So here we go. And where is Visual Studio Code is gone. No, here it is. Okay, Bicep files are quite cool. If you write a Bicep file, well, that's a font size that should be able to read. You have a parameter. You can have first you can define parameters and variables. Parameters you can pass when deploying your template from outside. And you see, for example, I've made the location a parameter, and I've given it a default value. So if I don't pass a value for that parameter, my resource will be created in West Europe. Otherwise, I could leave out this default value, and then I would be prompted to enter a string for the location when I deploy that template. Variables, you can see that I have string interpolation here. So for example, I say my data factory name is a variable, and here I enforce a naming convention. I say, okay, my data factory name should be ADF, then minus bicep to know that this is the one from the ADF bicep presentation, and then a unique string that comes from the ID of the resource group, just to make sure that if I run the same thing twice in two different resource groups, I get unique names. Same for my key vault. But hey, these are only variables. So let's have a look at variables. So at resources. So for example, I can also enforce tagging of my resources. But now the thing I want to do is, for example, I want to be able to use the storage account. Don't want to recreate the storage account because I want to use the storage account that that Alpa has created. So I say, okay, I define a resource. I give that resource an internal name. So this is purely my internal name that I can use for whatever I want. You can see that now I'm getting these yellow wiggly lines saying that storage account 123 is declared but never used. And as you can see here in red, I have an error in a different place where I wanted to reference that storage account. So I'll just revert to the old name. But this is a purely internal name. And then I say, what type of resource is it? It's a resource of Microsoft.storage/storage accounts, and I give an API. And here's the big question, which API should I use? I'll give you the answer that I found for myself. For myself, I found the answer, it doesn't matter. I'll just use the latest one. I've never had breaking changes occur. I've never had things not working due to incompatibilities. So when I write a template, I'll just use whatever the highest number is in there at the time of writing, and then I see what happens. But usually this is just what works. And then I give the keyword existing, meaning that this is not a resource I want to create. It's a resource that's already existing that I want to reference. And I give the name to find that existing resource, and that's, of course, in a variable. So this is Alpa's storage account. It's an existing resource. I do the same for the SQL Server and for the SQL database. Okay, now I have 3 existing resources that I referenced. Now I create my key vault. My key vault will have a name, the key vault name that I've created with the string interpolation up here. We'll have some tags that I defined here. And you can see that I'm using variables as often as possible to ensure that things are really done in a consistent way. It's created in a location that was defined as a parameter. You can see param location string, so apparently this is the parameter that's used, and here you can see it's a variable that's used. And I can set access properties, and that's quite interesting. I can say, okay, I want my data factory identity, the ID of the managed identity of my data factory, to have permissions to get and list secrets. And the interesting thing about that is I've defined the key vault, but I've not yet defined the data factory. So what Bicep does under the hood, it knows that in order to create this object, it needs to create the data factory first, and it will create the objects in the right order. I define the state that I wish my resource group to be in. I want there to be a key vault with access policies for my data factory, and I want there to be a data factory, and Bicep and ARM will figure out in which order to create all those objects. Now I create secrets in my key vault. So I create a secret, and it's of type Microsoft Key Vault Vault Secrets. My secret has a name and it has a value. And in the value, I reference the storage account. And I reference the name of the storage account, and I get the keys for that storage account, for example. Same thing for the database connection string. That, and I'll have to give a word of warning here. I've done something that's really, really bad. You should never do that. Don't try that at home, kids. I've set the username and password as variables. Of course, they should be parameters without default values. And you should not pass them on the command line. That's rather important. This is not best practice what I'm doing here. This is just for simplicity. I wanted these to be available for me, and I'm too stupid to remember demo passwords, so I have them in here for later reference. But if you do this in a customer or in a production or in any environment, do not use variables for usernames and passwords. Use parameters and don't pass them on the command line. And then I create the data factory. And you can see that's pretty simple. It's, of course, of type Microsoft Data Factory Factories. It has a name, tags, and a location. And it has an identity that's a system-assigned identity. That's a managed identity. That will then be used to give access to the key vault. And then I create linked services of type Microsoft Data Factory Factories Linked Services. And the linked service has a name, and the name has a pattern. So data factory name / key vault linked service name. It depends on the data factory. And it's of type Azure Key Vault. And the base URL is the vault URI from the properties of the key vault. Simple as that. Now for the storage account, basically the same thing over and over again. create a linked service. It's of type Azure Blob Storage. The connection string is a key vault secret, and I reference the key vault linked service and the secret of the connection string, and the same for the database. Now with these 2 lines of code, we're in the same place that Alpa was before. We've created a data factory, we've created linked services, and we've enabled Data Factory to access our key vault and get the connection strings for our linked services from the key vault. Alpa, back to you.
Yeah, thank you. Yeah, so now we create our data set. So for that, we're going to author tab and we are creating data set by just clicking on these 3 dots. So here we can make a folder structure as well, because if you have a huge like pipeline more than limited, like more than 50 or like that, then it's like quite less space. Same for data set as well. So better to have arranged them in folder structure. So you can create data set by just clicking here and you select your data source, which is blob storage. And then you select file format. So these are the formats available at the moment. So let's see a CSV one. And then here you can give a suitable name and you select your link service, which is a blob storage related. And here you can point out like your container name as well. So like this is our container name and this is our file. We can parameterize it, but for in this example, we just selecting a particular file, and file has a header as well. So we can select that. And here you can use like a schema. You can have a simple file with a schema, or you can have directly with this file as well. And or you can select none if your data source is for a sync data type, sync as a, for a sync or destination one. But this is for source data source. So that's it. So we select like this way, and you can see here. You can give a suitable name as well. You can add description as well, and here you can see more information as well, like you can have a encoding or escape characters or row or column delimited as well if you have a different one other than comma delimited. So
And
that's it. Yeah.
maybe for those of you who've worked with Data Factory before, the descriptions can be quite useful. In my GitHub repository, you'll find a small tool that goes through the repository of your Data Factory and reads all those descriptions and then creates documentation from that in Markdown automatically, which is quite nice if you
Yeah.
have customers who want documentation.
Yeah, that's very good. Yeah.
Okay, so
Yeah.
maybe I'll show how to create the
Yeah.
linked the data
Dataset.
sets now.
Yeah.
So let me take over again.
Yeah.
And it's fairly simple as well here. And most of you will have guessed by now, if you want to create a data set, it's of type Microsoft Data Factory, Factory's data sets. So no big surprise. It has a name that's data factory name / dataset name. It depends on the data factory and the linked service for the storage account. Often you can just skip the depends on. I like to put them in for some things because it clarifies when reading, but that's not really required. And now I have properties. So my data set is of type delimited text, which is the same that Alpa selected. It uses the storage linked service. And I give the location. The location is a blob storage location, and I give the file name and the container it's in. And I could also give a directory if there is a directory. And then I have all those settings that Alpa just showed, like column delimiter, escape character, is there a header in the first row, how are strings quoted. So I can set all these properties, and then I can create a schema. So basically, I can give the schema explicitly, or I can say just say read it. But here I decided to put it in explicitly, and I just wanted to show the quality of the Visual Studio Code integration for Bicep. If you're writing a Bicep file, then you can see that Visual Studio the Bicep extension for Visual Studio Code basically gives me all the options that I can input here that I didn't set already. So that's also really nice because it gives you a good idea and also some documentation about what are the values that you can set here. So that's really helpful when creating those template files. And with that, I've added the data sets to my data factory. So Alpa,
Yep.
over to you again.
Yeah, thank you, Ben. So now we have a link service and we have a data set. So now we're going to create a pipeline having a copy activity. So for that, you can create your pipeline by just clicking here, or you can browse from ready-made template as well. But let's do like this way. And these are the activities which I said you earlier. So you can see you have data movements activity and transformation activity. You can have Azure function. You can have a data breaks, and you can have a general activities, which is like these are the general activities which we use for Azure Data Factory.
And the most important one in the general is probably the execute pipeline, because that enables you to chain different pipelines and to run different pipelines depending on each other.
Yeah, parent-child pipeline. Yep. And this is iteration and conditional one. So let's do copy activity. So for that, we have a copy activity. So you can drag and drop like this way. And here you can select your source and your sink. You can give suitable name as well. And let's select our source. Our source is blob storage. And at the moment we are selecting file directly, but you can have other option as well if you have a list of files in your container then. And you can have pattern matching as well, and you can have based on prefix as well.
And you can add parameters to a data set and set these parameters, for example, in a for each loop. So you could like have a list of files from somewhere and set the file name from in the for each loop to the current value. So that's also use cases that are very typical.
Yeah, and I think it's always better to use parameters and variables and make your pipeline dynamic rather than duplicates. Otherwise, these are so many pipelines and so many data sets and link services. So it's difficult to maintain them. So yeah, possible then you should use a parameterization. Yeah. And so at the moment we haven't used parameters. Otherwise, you can see parameters in here. So let's go back. And so that is our source setting. And now this is our sink setting. So we are going to write down into Azure SQL database. We are moving a data into Azure SQL database. So our sink data set or destination data set is a Azure SQL database. And here we have already table available. So we not using this option and we only inserting it. So we using this option, but you can do insert upsert as well, insert or update as well. Or if you have store procedure, then you can use this option. And these are the option for a performance related. If you have a huge amount of data and if it's timeout, which is by default 30, then you can increase here 60 as well. You can increase batch size and maximum concurrent connection as well. So let's move here. So we are inserting a data. So we selecting this option and that's it, I think. And we can rename as well. So let's say copy data. And so that's it. So now you can debug your pipeline by just clicking on this button. So it will move a data from our blob storage to our Azure SQL database.
And while the data is moving, let me quickly show how to create the pipeline in Bicep, because we don't want to take longer than our planned 60 minutes, because we don't want to take any time from Johan.
Yeah.
So let me show. That's fairly simple. So my pipeline, surprise, surprise, Microsoft Data Factory, Factories Pipelines. Give it a pipeline name, depends on Data Factory, 2 data sets, and it consists of an array of activities. And the activity here is a copy data activity. It's of type copy. I can give a name here. That could also be a variable if I want that. And I say the source is a delimited text source, and it's the sink is a SQL sink, and I can set all the parameters that Alpa set before. I can say, okay, for the inputs, I reference my data set for the blob, and for the outputs, I reference my data set for the SQL database, and those are data set references, and basically that's already all I need to create the pipeline. Alpa, over to you.
Yeah. Okay. Thank you, Ben. So yeah, so my copy activity has successfully run. Here I can monitor and I can see that source is blob storage, and my sync data source or destination data source is Azure SQL Server, and it's successful. You can see how many data read and data written, and here you can see that queuing time and transfer time as well. So now let's double check in a database, which is this one. So earlier I have deleted, so it was 0, but if I run now, then you will see that it has 3 records or something like that. So these are the record which move from my source file to a blob storage source file to Azure SQL database. And you can see data as well. So this is the copy activity. So now I would like to hand over to Ben again.
Yes,
Yeah.
thank you. Wrong window. I'll share my screen, and the thing that's left for me to do is basically to run this command that I've commented out in the last line of my bicep template, which will deploy my bicep template. So what that does is it creates a deployment on the group level, so on a resource group. I pass the resource group that I want to use, and I pass the template file that I'm just working in, and I can set my parameters. And I've mentioned this before, but I would like to stress it again. If you have your passwords or usernames as passwords, as parameters, don't pass them on the command line, because they will be in your command line history, and that's not best practice. If you just leave them blank, you'll be prompted when you run that command. So let me run that command. I've already opened the PowerShell, logged in, and here's my command again. Zoom in a little bit. Now what happens is, hopefully, I've not tried this today, but it's always good to what? Underscore. I've mistyped the name. That's why you always never test your demos. What's happening now, hopefully this time, is that the templating engine will try to figure out what resources are needed, what resources do I want to create, do I need to create, and then it will start creating the resources in the right order, creating all the permissions that we need and everything, like, for example, the managed identity, give that access to the key vault and everything. And in the end, after a few seconds, when this whole template has run, we'll have a data factory with linked services, with data sets, with pipelines. We'll have a key vault with access permissions for the data factory, and we'll be able to have a look at that in a moment. But while we wait for that, Alpa, I suggest we show the closing slide. We conclude with our final remarks, and then we'll show what's created from the template. Because if the deployment fails because I've messed up the template again, that will give me a chance to pretend this never happened.
Yep. So
I
with
like
that,
pretending mistakes never happened in a demo.
so with that, let's move to conclusion. So you can see that Azure Data Factory, you can UI, which you can do like no code, raw code solution. You can drag and drop a few components and you join them. It's Azure Platform as a Service, it's serverless, and you can use it for your data movement, data transformation, data orchestration, or automation, your workflow or pipeline.
Or
And
just in one sentence, Data Factory is great. Use it.
yeah, yeah,
We
it's
can
a
agree on
really,
that.
yeah, yeah. And you can do with biceps way as well if you are,
Yeah.
yeah,
Can you
you
advance
are,
this? Can you advance the slide?
yeah.
Yeah, Bicep is great too. It's a cool way of defining resources, so use it
Yeah,
too.
yep.
And the final conclusion then for me would be, we have two great things, we combine two great things, the result is also great. So do that if you have a use case for it, like wanting repeatable deployments of Data Factory environments
Mm-hmm.
to roll out to customers, to give to customers to roll out in different environments, stuff like that.
Yep.
If you have a use case for that, it's a cool thing to do that. And with that, I can share my screen.
Yep.
So from that, you can conclude that my deployment did not entirely fail, because otherwise I would pretend that we ran out of time. So you can see the deployment completed and output a lot of stuff here about the resources that were created and everything. So you can browse through all that output, or we can go to the portal, which is what I want to do now. We can go to the portal, refresh that resource group, and we can see a new key vault that is called Key Vault Austria, because today we're with the kangaroos in Austria, right? I can look at that key vault, and I can see, for example, that where is it? I can't see. Access policies. Sorry. I can see that there is an access policy for a data factory that's called ADF Bicep minus IZFLC77 something, and that's the unique string made from the name of from the ID of the resource group. And you can see this new data factory that you've just seen in here. And if we look at that, you can see that we have linked services for Key Vault, for SQL database, for storage account. And you can see that we have datasets for file and the blob storage, that we have a dataset for SQL database, and that we have a pipeline that contains a copy data activity that copies from the blob storage to the SQL database. So apparently the template that we've just deployed did the same thing that Alpa did manually. However, it did it in a repeatable way. And if we want the same deployment, the same pipeline, the same data factory in a different region, in a different resource group, it's just a matter of rerunning this command and changing the location or changing the resource group. And that's quite a nice way of creating even data factory resources. So with that, we've reached the end. We're 1.5 minutes early, which gives you time for very quick questions before I'm happy to listen to what Johan has to tell us.